Today we're going to be solving compound inequalities. A compound inequality is an inequality that's formed by the joining of two inequalities using the word and or the word or. When two inequalities are joined by the word and, it is called an intersection, okay? Because we're going to look at the two graphs separately and we're going to graph only numbers that are solutions of both inequalities. Basically where the two graphs would intersect become our solutions. So here we have 2 is less than or equal to x, which means that x could be 2 or anything larger. And we have x is less than 5, which means it can't be 5, but anything less than 5. So here in the middle, between 2 and 5 is where they cross over. But x can't be 5, it can be 2, so I use a closed circle at 2 and an open circle at 5. This right here is the graph of 2 is less than or equal to x, but x is less than 5. Now if we use the word or, it's called a union. So our answer is going to be a solution of one inequality or the other. So here we have y is less than or equal to -2. So y could be -2 or anything less, and y is greater than 1. So it can't be 1, but it could be anything greater than 1. And if I look at my compound inequality where I have y is less than or equal to -2 or y is greater than 1, I see that actually both solutions for these inequalities are graphed on this one. All right, so let's look at writing and graphing compound inequalities. So here's an example. They're telling us a number x is greater than -8 and less than or equal to 4. So I see the word and, I know this is going to be an intersection. So I first was told x is greater than -8, so I wrote this as an inequality. And x is less than or equal to 4, so I wrote this inequality. And together, when I put them on the graph, I have the numbers between -8 and 4. It has to be greater than -8, but less than 4. So in between those numbers, I'm using a closed circle at 4 because it can be equal to 4, and an open circle at -8 because it can't be equal to -8. So let's look at another one here. It says a number y is at most 0 or at least 2. So this time I know that it's not going to be an intersection, it's going to be a union. So they first told us that y is at most -2. So y is at most 0. So y is less than or equal to 0. And it's at least 2. So that also means that at the smallest it's 2, so y is also greater than 2. So when I go to graph these guys, the y is greater than 2 is going to be going to the right. It can't be 2, but anything larger than 2. And it can be equal to 0 or anything less than 0. So going off here to the left. And this one is called a union because it's a solution for this inequality or this one. So let's talk about solving compound inequalities with the word and. So we may see an inequality like this where it's telling us that x minus 2 is greater than -4 and at the same time less than 3. This is basically a way of writing our compound inequality when we're using the word and. So in order to solve this one, I have to isolate my variable, get x by itself. So I'm going to add 2 to all of the sections of my inequality here. So I'm adding 2 to the -4, I'm adding 2 to the middle section, and I'm adding 2 to the 3. So on this side I'm getting -2, here I'm getting x by itself, and here I'm getting 5. So x has to be between -2 and 5. It can't be equal to either of them, so I use 2 open circles on my graph. So on this one, they're telling me -2 times x plus 1 is greater than -3, but less than or equal to 9. So the first thing I need to do is isolate my variable. So I'm going to subtract 1 here, but I have to do it to all sections of my inequality. So I'll subtract 1 here, and I'll subtract 1 here. So now I have -4 is less than negative 2x, which is less than or equal to 9. So now I'm going to divide by negative 2 to get x by itself here. And that means since I'm dividing by a negative, all of my signs are going to reverse. And I'm going to divide each here by negative 2. And negative 4 divided by negative 2 is 2. I have my x by itself in the middle. And 9 divided by negative 2 is negative 4.5, or negative 4.5. So basically x is between 2 and negative 4.5. I'm going to have a closed circle here at the negative 4.5 because it could be equal to negative 4.5, and an open circle at 2, and x can be anything in between those two numbers. All right, let's look at solving some compound inequalities that use the word or. So when they're using the word or, we're going to have two separate inequalities at all times. So we have 3y minus 5 is less than negative 8, or 2y minus 1 is greater than 5. So I solved them both separately. So the 3y minus 5 is less than negative 8. I added 5 to each side. Then I had to divide each side by 3, and I came up with a solution of y is less than negative 1. On this one, I added 1 to each side, and then I had to divide each side by 2, so I came up with the solution y is greater than 3. Now in both cases, y is not equal to the negative 1 or negative 3. So it's either less than negative 1, so going to the left here, or greater than 3, going to the right here. So let's try another one with or. So this time I'm starting with 2p plus 1 is less than negative 7. So let's solve this guy first. I'm going to subtract 1 from each side, and I'm going to have 2p is less than negative 8. I'm going to divide each side by 2, and I get p is less than negative 4. All right, let's solve this one. So first I'm going to get rid of 3 on each side. So I have negative 2p is less than or equal to negative 4. And I'm going to divide each side by negative 2, which means that my inequality sign is going to flip or reverse. And p is going to be greater than 2, or equal to 2. So first, let's start with this one. P is less than negative 4. So not equal to negative 4, but less than negative 4. So I'm going to highlight to the left. And then p is greater than or equal to 2, which means I have a closed circle at 2. And I'm going to highlight everything going to the right.